Hello everyone, welcome to my YouTube channel. And the question for today is binary tree with factors. So, given an array of unique integers ARR where each integer ARRI is strictly greater than 1, that is given. Alright, so and we have to make the binary tree using these integers. Alright, we have to make a binary tree, and the condition given to us here is each non-leaf node value should be equal to the product value of its children. So what does it mean by that is that each non-leaf node, suppose this is a tree and these are the leaf node, and this what we say is a non-leaf node should be equal to the product of its children. In this case it's not. If the tree was like this, where 4 is a non-leaf node, the value of this should be equal to the product of these two. Alright, this is what it means by that. And these numbers are given to us in a form of array, and each number is strictly greater than 1. Why we are given strictly greater than 1? Because 1 is a factor of every number. So if we include 1 in the array, we can have endless number of possibilities, and that will hamper our answer. So all the numbers are strictly greater than 1. That's why this condition is given also. And we are given unique integers, not duplicate values, that's for sure. And we have to return the number of binary trees we can make. So we have to return how many trees we can make given an array of numbers. All right, and the answer could be modulo of 7. This is because if the sum is a long value, then we return the modulus of the final answer. That's it. That is why this is given. I hope the question is clear now, and let's see what it means by this. So given this example 2 comma 4, as we can see here, we can make one tree like 4 2 2, and also these numbers can be used any number of times, n number of times. There is no restriction that this number has to be used once, twice, or like that. All right, so in here also, as you can see, it returns 3 as 2 4. The condition is on non-leaf node, not on the leaf node, so we can consider leaf node as one of the answers. All right, so this is the condition, and let's see what are the constraints given to us. So the constraint, very important thing, we have to, I'm telling again and again, we have to look for the constraints, and it will help us to make our corner cases. So the array length should be minimum of 1 to 1000. So it can be 0, so we have not to put a check where the array length is 0. Alright, it can be 1 and it can range to 1000. Alright, and the values that are strictly greater than 1 can range from 2 to 10 to the power 9. Alright, so 10 to the power 9, that is the things that are given to us. So how we are going to solve this problem? Let's see the approach for this. So the approach where we are going to use for this question would be a dynamic programming approach, because we have to return the different combinations and permutations. So we will use the dynamic programming approach for this question. Let's see how we will solve this with the help of an example. I have written something, let me clear it once, I'll explain it again. So one thing that we should do here is that we should sort our array initially, because if we were looking for some number, then we will go in a manner less than that, because only that numbers, because if we are at 5, we will only look for the numbers that are less than 5, because only that numbers could multiply and give us the value 5. So we are sorting our array in an ascending order. Alright, now let's take our DP array. So the DP array would be for every value, like these are 4 values, so it would be of length 4 0 1 2 3, and we know that in the test case it was given that it was for every leaf node, every non-leaf node. So this can be a 2, 4, 5 and 10 can in turn be a leaf node for their own. So for them we have to put a by default value for 1, because if there is no combination, then we can return the sum of the length of the array, that is 4, which will be equal to, so we will be fill these value by 1 unit. I hope it's clear why we are filling these values, because if we can't find any combination, if we, because in the initial case if there is no combination, that every node, every value can be returned as a particular uh, tree in its own. All right, so that's why we are filling their dp corresponding arrays with 1. Now let's begin our algorithm. All right, so it's sorted, and now see. All right, no, for we'll go traverse this with the value of I, and for j will range from this. All right, for every number we will look at the previous numbers that are less than that, because only that numbers could end up the result, and end up the factors of this number. So all right, let's see for here, because 2 has not previous number. Let's begin our algorithm from 4. All right, we are at value 4. What we see is, we see that if this number is divisible by 2 or not, because if this is divisible by 2, then only if we divide by it by 2, and let's see, 1 second, see, we see that if it's divisible by the previous number or not. Yes, it is, so it will return 0. Now what we do is, we just divide it and we get 2. So what we need to do is, we need to find this number. If we have this number, then we can multiply it with this and give our value this. So the tree would be like this. So that's why we are first checking for a number that that divides, or that more gave the remainder 0, that is completely that is a factor. All right, if it's a factor, then we will check for another number which will come by dividing them, and if that is present in the array, we will get our first combination. All right, so for 1 we will update our array like, because we have got one combination, what formula will we be using is, suppose I have one subtree over here and one subtree over here. Suppose its value x and its value is y, alright, at the node, and this value is x into y. Alright, so the number of trees would be this tree, this tree plus the multiplication of these two trees values. So we will do that only here. All right, so we will write the algorithm like, wait a second, we will write our algorithm in a way that dp of I is equals to dp of I, what value is there, plus the multiplication of the values of I by j and I by j, because that will be the and value of dp of j. All right, why I by j? Because it would be of another number, so we will check and we will get its index. So we will store these value in a hash map also, because we will not be looking at looping our whole array again and again. If we get a number which is percentage by 2, then we will just divide it and we will see that if this number is present here or not, and we can check it simply with the, if we have hash map of this. All right, so we will check here and we will get its index, and we will take the value here and update our final solution. Let's try run this approach on our question or not this example. Let's say 2, 4, 5, 10. All right. So here is the array, my DP array, initially filled with ones. I told you 1, 1, 1, 1. So let's start from here. So 2 is percentage by 4. It gives 0. So 4 by 2 gives me 2, and 2 is present in that. So what I'll do is I'll just take what the value of here is 1 plus what the value for 2 index is 1 into the value that I get by dividing them. 4 by 2, that is 2 only. So the value for 2 is again 1. So 1 plus 1 into 1, that gives me 2. So this value will be updated here. Alright. And now let's move to let's increment our I. We will see for 5 where we can't not now 2% 5 is not 0, 4% 5 is 5% 4 is not 0. So we will move again ahead. So now we are at this position. So 10% 2 is 0. So what we do is 10% 2 is 0. So what we'll do is we'll check 10 by 2, that is 5, that is the other value or the right value, because this is the left value by which we get the percent. So what we do is dp of I, that is 1, plus the dp of that is 2, that is the left value, that is 2 is 1, into the dp of right value. Right value is again 2, and it's present at index 0, so it's 1 only. So 1 plus 1 into 1, that gives me 2. Now it's stored as true. All right. Now again what we do is we increment our I, where it was here initially, then we go move to this position, then this. Now 10% 5 is again 0, so 10% 5 is again 0. So this is our left value. We will get its index. Its index is 3, and also 10 by 5, that is 2, which is also present, and its index is 0. Its index is 3, its index is 0. So we will do nothing, we will just 2 plus what is the value at index 3, that is 1, into what is the value at index 0, that is 1. So 2 plus 1 into 1, that gives us 1 into 1 will be 1. So 2 plus 1, that is 3. So this will be updated to 3. So the final answer would be the sum, because if there is no combination, then 1 plus 1 plus 1 plus 1 gives us 4. Now we have the combinations, we just sum them. So 1 plus 1 2, 2 plus 2 4, 4 plus 3 7. So the answer for this is 7. I hope this test case is clear, and the combinations how we have made, and this is the test case only. Let's see that we have answer 7 for it or not. So yes, this is the test case that I used, and the answer is 7. Alright, how we made this and how we updated them, I hope this approach is clear. This is a very important question for competition point of view. We are doing nothing, we are just using the conditions that are given to us and computing our results. Alright, and I hope it's clear to everyone. And let's see the code for this, and it would be much more clearer then. So this is the code that I have used here, and this you can see is a modulo value only. 10 or 9 plus 7 is this value. Don't worry for that. And we have taken length because our DP array will be initialized with this only. We have sorted the array because we want the values to in ascending order, or because for the value if we are at 5, we will look for the values that are less than 5, because that only will multiply with any number and give us 5. So that's for them. And we are filled DP array for 1. I told you that also, because for every node we can return a new tree which is the root only and containing no child and everything. So I have filled my DP array with 1. Alright, now I have taken a hash map and I have stored my index of every number that is occurring, because at that index would be its DP value that could be get and be used to compute my further results. Now this is my main loop. In this loop, what I am doing is, this is the outer loop, that is for the numbers that are present in array given to me. So it will just increment it. The another loop will be run from 0 till where I suppose I am at 10. This is array. So it will run for this position, and this position. It will check for every value that if its percentage is 0. If its percentage is 0, then it will find the another value that is the right. So if it is contained in my hash map, only and only then I will compute, because if I have no other value, then how can I compute my result? Because suppose the number is 12 and we are at 4. All right, so 4 by 12 gives us 3. We will check if 3 is present. 3 is not present, so we cannot make this tree. So all right, and hope it's clear. And now, and this is nothing, this is but the dp of I value would be dp of I plus dp of j, that is the index at j, and the value for that, and we will get for this value which is contained in our hash map, and we will add them with that formula and store them by modulating them, because when we sum them and just find our answer, it would be very much easier. So at the end we do nothing, we take our answer variable to be long, because the numbers are 10 to power 9, so in the array, so we compute dp for them, it could be much more bigger numbers. So that's why we have taken an answer variable as long, and for each loop has been implied, so an answer has been computed, and at the end we have just percentage it with the modulus value, that is 10 to power 9 plus 7, and as returned as int variable. So let's submit it. As you can see, it's accepted. So it's a very important question. I hope it's clear to every one of you, and if you have any doubts, you can ask me in the comment section. Please like this video, share it among your friends, and subscribe to my YouTube channel. Thank you for watching. Bye bye.